Welcome back, my wonderful students. We're now going to be pretty much doing the same thing that we did before, but this time we don't know that the triangles are similar. In our last example, we already knew that our quadrilaterals were similar because I gave you a similarity statement. So on this one, we want to know, are these triangles similar, which we really want them to be similar because it's kind of sad when things aren't similar, right? All right, and then also, so we're going to determine if they're similar by showing, are the sides proportionate and are the angles congruent? So all three sides must reduce down to your same fraction when you compare corresponding sides, and all three corresponding angles must be congruent. So let's see here. If I look at my picture, I have one arc on these two angles. I have two arcs on these two angles, and I have three arcs on these two angles. So, guess what, you guys? All angles are congruent. So we're on our way to be showing that these two triangles are congruent, which is really exciting. I hope that the sides end up being proportionate, so these are similar triangles. But we'll have to see. I don't know what will happen. Okay, so what I'm going to do, I'm going to write all three of the sides for the first triangle. Okay, and then I need to write underneath these which sides correspond to these three sides. Okay, I want to know which sides relate to these three sides in the triangle, which you can't assume, just by the way the picture looks if it does not say drawn to scale. So watch yourself. So the way that I personally figure out which sides are corresponding, I compare like 45 is my biggest side on this triangle. So what is the largest side on my smaller triangle? It would be the 25. So 45 would be over 25. Okay, now 40 is not the biggest side and it's not the smallest. It's kind of like the middle side length. So which side length is not the biggest and not the smallest, or your middle side length on the smaller triangle? Holy hot dog, you guys, it would be the 20. All right, and then lastly, my smallest side on my first triangle is 27. So what is the smallest side length in your other triangle? It would be a 15. Now, currently, looking at these fractions, it does not look like the proportions equal each other. It does not look like we have the same scale factor, because if you look here, all three of these fractions look different. But something that we need to keep in mind, always reduce down your fraction if possible. Okay, because maybe, just maybe, I don't know, we'll have to see, but maybe if I reduce down my fractions, they will all end up being the same value. So let's see what happens. So what is the number that divides into 45 and 25? It would be a 5. So I'm going to divide the numerator and the denominator by 5, which 45 divided by 5 will give me a 9, and 25 divided by 5 will give me 5. So this fraction reduces down to 9/5. Okay, so if the remaining two fractions also reduce down to 9/5, that means that my sides are proportionate. And since I have shown that angles are congruent and sides are proportionate, that would mean that my two triangles are similar. So let's see what happens. I really hope it works out. I'm really banking on this, you guys. Okay, so what is the number that divides into 40 and 20? Precisely. You guys are so smart. It is 20. Okay, so I'm going to divide 20 into 40 and 20, which 40 divided by 20 is 2, and 20 divided by 20 is 1. Oh no, I have a different fraction, which already tells me that my sides are not proportionate, which means these unfortunately are not similar triangles. But I'm also going to show you that the third fraction doesn't work out either. So a number that will divide into 27 and 15 would be 3. You guys are right. So 27 divided by 3 is 9, and 15 divided by 3 is 5. Okay, so these two fractions did reduce down to the same number, but my other side lengths did not. So all three side lengths have to be equal when you divide the proportionate sides, or the corresponding sides, I guess is the right way to say that. Okay, if they don't all end up reducing down to the same number, then your sides are not proportionate. So my sides are not proportionate. They did not have the same scale factor, which means that these two triangles are not similar, which is really sad. I hate when things don't work out. All right, so example 2a didn't work out, but maybe example 2b will work out. So let's see what happens when we look at example 2b.